This meeting is being
Sure.
recorded.
Okay, awesome. So, Suhail, you can start with your introduction. We'll talk in details. Okay.
Sure. My name is Suhail Arfaath. I have been working with Schindler Elevator Corporation since 3 years. And
Mm-hmm.
then, as part of my role being data scientist, I have worked on multiple different projects. I was kind of playing dual role. I was doing data science, and at the same time, I was also building large language model chatbots,
Mm-hmm.
especially for Schindler Elevator Corporation. I have worked on the projects where I was trying to predict the elevator failures, and I was giving this data points to the deployment team so that they can do some preventive maintenance and preventive care. And that was like one of the project where I was working, and the other project was to basically understand and try to see the supply chain and forecast of the materials and parts of the elevators.
Mm-hmm.
So we need to stockpile the parts in our inventory. So I had a model running which basically lets me know, like, based on the current trend, based on the past 7 and 30 days trend, how the parts and materials would be in shortage. Or I basically classify finally into three classes, like any specific part is adequate in the inventory, or it is understocked or overstocked. So these three would be the final outputs, especially for the supply chain parts management project. Why? Because especially we need to import all the parts from China. It again has like different parts like chips, conveyor belts, and then a lot of different things again. So that was, I would say, like 30 to 40% of my role. As of now, everything is already set up in the system. It was running beautifully fine. I just need to run the batch jobs every now and then. Even the batch jobs are scheduled by AWS Glue and stuff. And then I just monitor them on a day-to-day basis. And then I at times see the model accuracy. And if the model accuracy is drifting, then I just update with the new models. And apart from this, I was also building LM chatbots, especially for the local teams within Schindler. And these chatbots are primarily facing the internal teams. I was building for legal compliance, HR teams, and sales and service teams. So these chatbots, basically, I did both. I fine-tuned the chatbots with the open source models, and at the same time, I also attached the RAG vector storages. And I faced a challenge, especially like parsing the documents. There were like hundreds and thousands of documents which I need to uh, these unstructured documents. They are like image files, documents, scanned images like .tiff files, which are just like an image over the PDF document, uh, and .md files and JSON files. So I used to parse all of this information. I used libraries like doctr and docling, uh, which basically parse the documents and then which outputs the actual text from the document. So they basically parse the images and documents and then give me the output file as text format. And then I used to load these text chunks into the databases. And especially in terms of like database, I used PostgreSQL with PG vector extension to store all the vector tokens with the embeddings and chunks to the vector storage. And earlier to 2025, I was primarily using everything ad hoc. Like I was using AWS ECS, Elastic Container Services, to build all of the components, different components to the chatbot. Like I was using LangChain, LangGraph back then. And apart from this, I also experimented with a lot of different frameworks, especially like multi-agent frameworks. And I was experimenting with Crew AI, AutoGen, Pydantic AI, and all this modern frameworks. And then I only pulled LangChain and Pydantic AI at the end. Why? Because those were the exact things which I needed in this scenario. Why? Because I wanted to build a deterministic scenario of agents. And eventually, I evolved the agents into multiple agents. I was having the validator agent in the backend as well, so which basically gives scores. And I did set up the guardrails to the whole system. And around 2023, 24, I was using the open source models like Llama 2,
Mm-hmm.
Llama 3. And then after the managed services like AWS Bedrock became popular and became very stable, it made my life very much easy. And with Bedrock, I deployed a lot of models. And then our company was also using Azure Cloud, where all the teams were already utilizing Microsoft Teams. So I also built a lot of chatbots using uh, Microsoft Azure Copilot Studio as well, with the AI, Azure AI Foundry services. And these modern platform made my life pretty much easier nowadays. Instead of me filling down with all the nitty-gritty things like configuring everything within the Docker compose commands, setting up the API endpoints, uh, handling the vector storages, connecting it to the large language models. I used to do it manually, all of this back in 2023, but right now everything is streamlined. Everything is handled by the infrastructure, cloud infrastructure. So that
Okay.
is a short description demo
Very
about me.
nice and very great articulation, I would say, Suhail. Can you just walk me through your transition from data science to AI engineering?
So especially when I onboard with the Schindler Elevator Corporations, I was initially assigned with the data science projects. I was part of a team. I was working along with data engineers and DevOps engineers, and I was working on the project where I need to predict the elevator failure mechanism. And this was already set up in the system. It is not like I built something from scratch. It was already there, but I just basically upgrade the system. I utilized XGBoost model here, which is the ensemble modeling technique for especially boosting, bagging and boosting. It belongs to the boosting family of models. And with the help of XGBoost, I was easily able to achieve more higher accuracy. I was achieving like more than 90% accuracy most of the time, and which was more than enough for the current scenario and the use case. And then earlier to that, I already did my master's in data science. I experimented with with a huge set of models. There as well, I was working on different projects where I utilized the similar kind of models. So earlier to 2023, I would say I was working more on ML platforms like AWS SageMaker, and I was consistently training the model, evaluating the model, looking at the drift and all these terminologies and scenarios. I was working more towards machine learning modeling, regression and classification concepts. But around I would say like mid 2023, I pivoted more towards the Gen AI side. I was building LM chatbots. And
Yeah.
especially in terms of transition, if you ask me, the transition was pretty good, I would say. And especially on the data science side with the Schindler Elevator Corporations, everything is very much stable right now. All the models, pipelines, everything is well configured and working fine. And there is nothing much to polish there or evolve it into further things. So
Mm-hmm.
that's where I transitioned from that to towards the building of large language model chatbots.
Okay, okay, awesome. So, what are the challenges you face during this transition? Probably the new skill set, new tools and technologies. So, how did you cope up yourself? How did you manage those challenges?
So especially in terms of challenges, I would say definitely, like I was coming from the background of machine learning. I was pretty much curious on the deep learning aspect as well. I was closely monitoring like all the deep learning models as well. And especially right around 2017, the transformer model got released, and then I got to know about it somewhere in like 2020. And then especially when I started, I was having no clue about all of this stuff, but eventually the first thing what I did was I came up with multiple proof of concepts, which I still have in my local system.
Mm-hmm.
I started using LangChain, LangGraph. I was using Na10, Flowwise. I was building proof of concepts projects with the Crew AI, and I know very well all the different configurations of these things, like where Crew AI would perform best, where LangGraph would perform best, how Pydantic AI would add structured outputs to the existing uh, language models, especially when configuring your graph models,
Mm-hmm.
and then how where autogen falls. And nowadays these new things are coming, especially like multimodality frontier models. So I was also consistently exploring this, especially in this AI landscape. I would say these things are consistently evolving. So I would say, especially in terms of like transition, it was something new. It was, but I was familiar with the Python modeling as well as all of these models were already pre-built. Like I did not reinvent the wheel here, right? I just imported the LangGraph
Mm-hmm.
package, Pydantic AI package to my existing program, and then I just built the whole framework and skeletal system of the large language chatbot model. And right now,
Very
if you
nice.
see, I'm also upgrading my knowledge. I was also experimenting with the deep agents, which recently came from the LangChain team around March. So that is more towards like the agents can now plan for any given query. They can plan and then they execute all the stuff after they plan. So it is much more elaborative and it gives much more better reasoning out of it.
Awesome.
So
Awesome.
uh,
So, how would you differentiate supervised and unsupervised learning?
So especially supervised learning is something where you have your predictor label, like your output label already predefined. And
Hmm.
you will have all of your input variables and your output variables already predefined. So with supervised model, it is, I would say, uh, you already have the predicate defined. So you feed your model, you train your model on these specific attributes and your output label, and the model now fits over your existing data points. And once your model fits, uh, and from then onwards, when you give any new input values, then it will give you a specific output.
Mm-hmm.
Uh, and when in case of unsupervised model, so you don't define any output variable or output label especially. So you let the model figure out the output variables here, especially in terms of unsupervised learning techniques. So again, classification and regression fall under supervised learning techniques, and under unsupervised learning techniques, I would say like uh, clustering, anomaly detection, and association rule, they fall under
100%. Yeah, yeah,
unsupervised
yeah,
learning.
yeah. How would you define overfitting?
So overfitting is kind of a phenomenon when the model tries to exactly fit over each and every data row or each and every transaction what you have so far. If
Mm-hmm.
your model overfits, then it basically sometimes gives us more uh, more not true attributes. So especially to avoid such kind of overfitting models, we try to come up with better evaluation metrics. Like we try to implement like a model's accuracy, precision,
Mm-hmm.
recall, F1 score, all of these kind of evaluation metrics. You
So
strictly
these
look towards
evaluation
it.
metrics, can you define little bit more precision, recall, and F1 score?
Okay, these are like somewhat formula intensive, but let me try to recall. So especially like plain accuracy sometimes won't help out. So that's where we try to utilize the precision and recall. And precision is again also, I would say it is called as like type one accuracy, type one error, sorry, type one error, where we try to see how well the model is telling, especially with the true positives. And the formula is somewhere around like it is based on the confusion matrix again, like true positive by true positive plus uh, false positive. So that is the exact formula, and it basically tells us like what is the true positive rate here. And recall especially, it tells us like how well the model uh, is identifying the false negative cases in this scenario. Like the formula would be true positive um, by true positive plus false negative. So these two metrics go hand in hand, and I basically utilize this specific metrics when evaluating my model. Along with these two metrics, I used to basically check the ROC and AUC curves, which is nothing but uh, the formula is again what is the formula, like precision precision into recall by precision plus recall multiplied by 2 times, which is nothing but the area under the curve. And if my model spits out like more than 90 above 90% accuracy, then I'm satisfied, and then I just close this whole experiment out. So that's how I utilized uh, precision and recall, especially to evaluate the model's accuracy.
Okay, okay, awesome. And what are the ML algorithm you have implemented so far? Can you just walk me through any one that you have implemented?
So especially in terms of machine learning modeling techniques, I would say most of the times I was primarily utilizing the regression techniques. I have like basic idea of all the different models, but in terms of implementations, I have used XGBoost most of the time for most of the scenarios. Why? Because XGBoost is like you don't need to reinvent the wheel again. It's already well defined. I just need to give the input data set, mark it all my labels. I used to do some feature engineering here and there. And then I used to add some lag variables like past 7 days trend, past 30 days trend to the model. I would say XGBoost is the primary model which I have good expertise on.
Hmm. Okay, okay, awesome. So, how do you validate a model performance?
So especially here, again, you are talking in terms of like the large language models or in terms of
Machine
like
learning
the machine
models.
learning model. So in terms of like machine learning models, I definitely, as I've already told you, like I evaluate the model based on different aspects. Like the first basic thing is accuracy, where I check the model's accuracy based on the true positive and true negative scenarios. Like the formula for accuracy is again like true positive plus true negative by true positive plus true negative plus false positive plus false negatives. So this basically gives me the accuracy of the model along with the mean squared error. And I also utilized other evaluation techniques like precision recall, F1 score, as well as ROC, receiving operator characteristics. And I was also utilizing the area under the curves to primarily determine how well my model is fitting, whether my model is performing well or not, and then what is the bias within my model, and how is the training data set, whether it is a balanced training data set or it is unbalanced training data set. And I was using all of this to basically evaluate my train test split for the of the data. I was evaluating my training data set at the same time. Before training itself, I used to evaluate my training data set, and especially when I run the model at inference, then I definitely try to use the kind of metric which I already specified, like area under the
Hmm.
curves, to primarily determine the
Very
accuracy of the
nice.
model.
Very nice. And how do you deploy ML models in production?
So especially in terms of deploying, like from right from the beginning, like I would say I'm pretty much a fanboy of AWS SageMaker pipelines from the early
Mm-hmm.
on. I saw SageMaker from different iterations back then, right from like around 2018, I would say. And even at Schiller Elevator Corporations, I was just primarily using AWS SageMaker pipelines. So within AWS SageMaker, the whole architecture is again within AWS. Uh, like the OLTP transaction, like all the data from the sensors, like every elevator has a black box where all the sensor information is directly streamed to the OLTP database. From there, we have the data engineers working. They pull these transactional data and then they post it to Redshift. And from Redshift, I used to have the materialized views where I add my lagging indicators, and then I pull the data from my Redshift and directly use it in my SageMaker pipeline jobs. And everything is already well set up and organized. I use AWS Glue jobs with Glue Catalog, where I basically schedule this job on a day-to-day basis, and then I pull all the data from Redshift, especially the window of data what I want, especially when training the model and validating the model. And then with the help of AWS SageMaker, I wrote all of my code in within my SageMaker, especially for training. And these jobs basically execute in real time with inference with AWS infrastructure. Everything is like serverless. I don't need to manage anything from my side. So the jobs basically run, especially at the triggered time. and then it gives the model output right away. And then I have again corresponding flows where I check the model's output against the inventory stockpile to see if the parts are available or not. Because as I told you, like sourcing the parts and materials, again, all the parts come from China, so it will take some buffer time, like 30 to 60 days. So we need to plan everything ahead here.
Okay, okay, awesome. When did you build ML pipelines last time?
So ML pipelines, I would say around like 2023, like that year specifically, I started.
Okay, so how did you do
Uh,
this?
I built. So how did you do this? In the sense, I directly kickstart with the AWS SageMaker.
Mm-hmm.
I already had my IPython notebook set up there, and within there, I just had different Python code where I pull the data into my SageMaker pipelines,
Mm-hmm.
and then I pull the data, and then I configured the model using XGBoost. Did the train test split right away, and then I schedule the training jobs within the AWS SageMaker. And if the model is very good already, and then I used to push the model to the model registry
Excellent,
if the
man.
accuracy is
I
pretty
just
high.
loved it. Can you walk me through your project, LLM projects that you have worked on? I know you started your introduction with this, but to be specific on LLM side, I would like to continue in this way. So just walk me through your LLM projects that you worked on.
So especially at the LLM projects, like right around, I would say mid 2023 onwards, I started working on the LLM projects. The primary use case with Schindler is Schindler has a lot of teams, a lot of internal teams, and then all the teams, they were basically using the non-compliance tools. Like they were using ChatGPT, they were using Gemini models, they were using all the external frontier chat models, which was not approved by the teams, and which were later blocked by the teams. So all the teams, they wanted to have a local model, local chatbot model, which
Mm-hmm.
is well trained, fine tuned on Schindler terminologies. Like Schindler is again like a elevator and manufacturing and electrical company
Mm-hmm.
where we manufacture elevator and products. So the
You pretty much
Schindler
articulated
terminology is
well.
different.
You pretty much articulated. I'm sorry if I interrupted you in between.
Yeah, that's
Can you
fine.
walk me through what is RAG?
So RAG is nothing but retrieval augmented generation. So
Mm-hmm.
especially, let's say when you fine tune your model, you're just trying to give the persona, the branding of the model to the large language model. But you need to have a knowledge base here. Your knowledge base will be your RAG pipeline, where this large language model could directly communicate to your knowledge base. And in your knowledge base, you'll mention all the details. So you can have your database transactions here. You can have your documents loaded into this retrieval augmented generation database. In my specific scenario, what I did was I basically converted all the unstructured documents. Like Schindler has thousands of documents.
Mm-hmm.
I built a proper channel and pipeline where I converted these unstructured documents. I stored all of these documents in my vector database, so that now the large language model now has a knowledge base which it can tap into, and it could basically call to this RAG database and then get more information about the question. Let's say now the customer asks like, hey, I need to know more about this specific compliance policy. And then now, even though if the fine-tuned model, even though if it doesn't have access, even though if it is not fine-tuned on that particular data point, but it now has access to the RAG vector database. So now it could directly tap onto the vector database. It can do vector similarity search, like cosine search or Euclidean search. And then it could basically, based on the user's query, it could exactly match the semantic tokens available in the vector database. And then based on semantic comparison and similarity index, it basically returns that specific data points to the large language model
Mm-hmm.
chatbot. That
Awesome.
chatbot again, it further fine tunes
Yeah.
the answer and then spits out to the customer.
Awesome. How do you reduce hallucination?
So especially in terms of like reducing hallucination, like I basically followed like multi-prong approach. So especially the primary thing which I did was to add Pydantic AI, which is a external package again, Python library. So with the help of Pydantic AI, I basically added the structured outputs to my model. And then I also added like guardrails, like basically like inbound and outbound guardrails. And in few scenarios, I also refine tune the model, retrain and refine tune the model so that the model is now well aware of all of these transactions. And I also have recorded all the customer conversations, which has like high coherency, high fluency, and high groundedness. So I have the data set of all of these well answered questions, which I again fine tune to the model. So by that, the model has now much more fluid data points to answer. And as part of the guardrails, I have added safety guardrails, uh, e- especially at the inbound system. Like I added guardrails like violence, sexual harassment, self-harm, indirect attack, and then like hate, unfairness. So these were some of my guardrails which I set at the inbound. Like if the
Mm-hmm.
customer does any prompt injection stuff, then immediately, let's say if the customer asks like, how can I harm someone? And then at the same time get unnoticed. Like if he asks such kind of a tricky question,
Okay.
the system, the large language chatbot model would block such queries at the inbound itself instead of going through the whole model multi-agent architecture here. It basically blocks such stuff at the inbound, and then it immediately gives a vague answer like, hey, this is triggering my safety violence flag, so I can't answer this question further. And then it gives like please, uh, you can ask me questions on so and so topics, not on these specific topics. So and especially like I also checked the models drift over time. We also had like observability metrics for using Langsmith here. We were continuously monitoring. Even we had the validator agent, which basically flags any of the conversations which look like toxic or which look like they don't have much groundedness or faithfulness.
Yeah,
It
you're
basically flags
excellent,
all of
man.
such
You are
conversations.
excellent. How do you evaluate LLM outputs?
So especially in terms of like evaluation, I already have like multiple metrics, like basically latency, models drift, and we were also looking at the tracings. We have a beautiful dashboard where it shows what is happening with this specific model, and then we used to consistently monitor this dashboard so that all the metrics are below 5% here. And
Awesome.
I would say we were again evaluating against both of these, like inbound and outbound
Yeah,
metrics,
I
which we
think
have
Swell,
already.
you covered pretty much, and I took almost 30 minutes, which was scheduled for just 15-20 minutes. Let me just stop the recording.